हाय फ्रेंड्स, वेलकम ऑन YourPedia। सो आप YourPedia पे देख रहे हैं कोल इंडिया लिमिटेड का मॉड्यूल जो YourPedia ने लॉन्च किया है। एंड देयर इज अ स्पेसिफिक रिक्वायरमेंट फॉर एवरी एग्जाम एंड वी लॉन्च टेलर मेड मॉड्यूल कोल इंडिया लिमिटेड के लिए भी। इफ आई टॉक अबाउट मैकेनिकल इंजीनियरिंग, then the requirement for particular subject in coal India is different from others. I mean the focus is on different things. जैसे आज का जो टॉपिक है मेरा वो कास्टिंग का है। वी हैव रेफरेंस ऑफ 2017 एंड 2020 पेपर। तो व्हाट वी विल डू, फर्स्ट वी विल गो फॉर क्वेश्चंस जो प्रीवियस ईयर्स के हैं, जो 2017 के हैं, 2020 के हैं। उसके बाद मैं आपको एक्सपेक्टेड क्वेश्चंस कराऊंगा जिसके थ्रू you will understand entire process of casting process, where the focus has to be, from where the questions are asked. And then this document will be important for you. Take this document and read this document, and there's a learning content will also be there in this document. That is how we prepare on YourPedia. To make this module very concise and precise, what we do is, like, mentors like me are making videos, half an hour, 45 minutes video, or 25 minutes to half an hour video. And once you listen this video, you will understand, okay, this is what is the point. And most of you are already preparing for various other exams, so you need to have some direction, like this is how you have to prepare for particular exam. So this is the advertisement of Coal India, and 11th June is the deadline till you can apply. And mechanical engineering mein there are very good number of seats, 145 seats. Only written exam is there, CBT is there, interview is not there, so you will get an advantage in that. So today's my lecture is about metal casting process. So many questions were asked from metal casting. Metal casting, as you know, is a part of production engineering, and many questions are asked from metal casting process. So you should be very confident in this. So let me first start with the previous year questions. So this was Coal India Limited 2017 and 20 question from metal casting. Sand and oxide layers adhering to casting are removed by which of the following processes? So particular layer, when casting is done, casting is a molten metal, in the mold, so it is a high temperature process. So whenever there is a high temperature process, molten metal will get oxidized, so atmospheric oxygen is there, and then there is a so it will make some kind of layer on the top surface, so we need to remove that layer. And the process to remove that layer is a short blasting. So basically metal casting is to be removed from the mold, and it has scaling, it has oxide layer which are to be removed by short blasting process, and this basically is the process for that. So impact cleaning, high velocity stream of abrasive particles are thrown. Abrasive action is kinetic energy of the shot, basically remove some kind of oxide layers. Surface preparation is to be done, uniform surface is to be produced. So this is something like short blasting. So if you see this side, left side, and if you see right side, there is a difference. So you get the clean uniform surface due to this very small abrasive particles impinging upon the surface. So when the size of the abrasive particle is very less, so they remove any kind of oxide, and the surface quality, surface finish gets improved. So any kind of scaling, oxides get removed in the short blasting, right? Short होता है आपको फेंकना, और blast मतलब ऐसे फेंकना किसी casting के लिए. So this is the raw casting, this is the finished casting process. That was the question asked. Which force is acting on core when metal is poured into mold cavity? So core क्या होता है? As you can see, answer for this is buoyancy force. So you can see this is the core. Core is used in the casting to produce the hollow cavity in the casting process. So this is the molten metal, और जब core आप molten metal में लगाते हो, when the core is there in the molten metal, obviously anything in the fluid, anything in the liquid will have buoyancy force. So buoyancy force will be acting. See all the diagrams carefully. There is a core print. So core print is basically that particular thing which helps to adjust the core against the buoyancy force. So core को यहाँ पे टिकाने के लिए, सपोर्ट देने के लिए core print is there in the mold cavity, right? So core is surrounded by the molten metal, and hence upward force acts, which is called buoyancy force. And core may float or get lift upward, and to avoid that, we basically give the support to the core through core print. And core print, chaplet and supports are provided to hold the core in the correct position. So please read these things very carefully. So chills are different, chaplets are different. So chaplet is to provide the support to the this core print, and chaplet are providing the support to the core so that core does not move when molten metal will apply the buoyancy force. The core remains in its position. उसको बोलते हैं basically chaplet. So chills and chaplets and core print, ये 3-4 नाम होते हैं that you should be very carefully knowing what is the meaning of that. उसके बाद गेटिंग रेशियो क्या होती है, व्हाट इज द गेटिंग रेशियो क्रॉस सेक्शनल एरिया से. इन कास्टिंग गेटिंग रेशियो इज द रेशियो ऑफ क्रॉस सेक्शनल एरिया ऑफ गेटिंग सिस्टम. तो दिस अ गेटिंग सिस्टम, स्प्रू, रनर एंड इन गेट एरिया, ये 3 चीजें होती हैं. डायग्राम में यू विल अंडरस्टैंड व्हाट इज स्प्रू, व्हाट इज रनर, व्हाट इज इन गेट. सो इफ द एरिया ऑफ क्रॉस सेक्शन ऑफ द स्प्रू इज AS, area of cross section of the runner is AR, area of cross section of in gate is AG, then ratio of AS, AR, AG basically gives you gating ratio. So gating ratio is sprue, runner, in gate. D is the answer. तो इनकी रेशियो को गेटिंग रेशियो बोलते हैं. तो ये डायग्राम देखना ध्यान से फ्रेंड्स. So this is a pouring basin and then aspiration you find here. I mean when the fluid flows here because of reduced cross sectional area, I want that the fluid when it is flowing pressure does not reduce less than atmospheric. यहाँ पे atmospheric pressure है, तो fluid mechanics में आप पढ़ते हो कि जैसे जैसे you come down pressure may reduce compared to atmospheric pressure if at cross section area remains same. So pressure does not get reduced to less than atmospheric, so cross section keeps on decreasing. That is called sprue. So sprue is this vertical section. So area of the sprue here is AS. एंड देन रनर इज दिस पार्ट, रनर ये पार्ट होता है तो उसका एरिया इज AR. एंड इन गेट जहां पे आपने एंटर करना है उसको इन गेट बोलते हैं. तो रेशियो ऑफ स्प्रू टू रनर टू इन गेट एरिया इज बेसिकली द गेटिंग रेशियो, राइट. सो दिस इज व्हाट यू शुड नो. सो पोरिंग बेसिन से स्प्रू, स्प्रू से रनर, रनर से इन गेट, फिर उसमें मोल्ड कैविटी इज फिलिंग, राइट. तो प्रॉपर गेटिंग रेशियो की रिक्वायरमेंट क्या है, सो दैट स्मूथ flow of the metal is maintained, turbulence and aspiration and erosion is avoided. Now what is aspiration? There is a term called aspiration. Aspiration, as I told you, जब a fluid will flow in in the sprue, when the fluid liquid molten metal is flowing in the sprue, if the cross section area remains same, then the pressure will reduce to sub-atmospheric level, I mean less than atmospheric, and the gases will try to enter into high temperature molten metal and further casting defects will be produced. To avoid that, area of cross section gets reduced, and you have designed that cross sectional area also in your casting. So aspiration is that particular phenomena. So you should know all these phenomena. ये क्या phenomena होते हैं. Which of the following is best suited for production of hollow pipes? तो centrifugal casting, hollow cylindrical components like pipes, tubes, liner, इनके लिए यूज किया जाता है. So due to centrifugal force, molten metal moves outward and forms hollow cylindrical shape. So ये आपका centrifugal, आपका इस तरीके से casting प्रोड्यूस होती है. Right, so this is the ladle. क्या होता है ladle, क्या होता है pouring basin, क्या होता है centrifugal casting, these things you should be knowing. So metal molds are used in which of the processes? Metal molds are used in which of the processes? In die casting, molten metal is forced into this reusable metallic mold. तो die casting होता है. So mold are of sand mold होते हैं. There is a different kind of material. wax के भी होते हैं mold. Investment casting will do where wax mold is used. एंड देन सैंड मोल्ड, ग्रीन सैंड मोल्ड उसको यूज़ करते हैं. तो मेटल मोल्ड इज यूज्ड इन डाई कास्टिंग एंड दे आर रीयूजेबल, यू कैन अगेन रीयूज इट. एंड डाई कैन वर्क अंडर हाई प्रेशर एंड these molds are non-metallic also, expandable also. So investment casting में ceramic mold are used and then wax. Shell molding में resin bonded mold is used. Sand में sand mold is used. So this is a diagram of die mold. So there is a plunger, molten metal is plunged into the cavity. So this is how there are ejector pins. So this is how die casting goes. So there are different casting processes, sand casting, die casting, shell mold, investment casting. So which particular mold is used in which of the processes, that you should be knowing. So to increase the heat extraction capacity of sand mold, what do you use? So chill is used for that purpose. So chaplet, I told you, chaplet is used to give the support to the core, so that core does not move because of the buoyancy force. Core does not move, that is the chaplet. And the chill is to basically extract the heat from the molten metal, so that directional solidification takes place. So the solidification of the molten metal takes place. Chills are metallic inserts, so that rate of heat extraction gets enhanced. So rapid cooling and directional solidification is obtained, and defects like shrinkage, cavity could be prevented. So you see this carefully. Chills are being provided, and this is a molten metal. Chills, when chill is here, molten metal will start solidification from here. So if I want that solidification should start from here, I'll put chill there. So जहाँ पे भी chill पड़ा होगा, solidification वहाँ से start होगा molten metal का, and I can control the direction of solidification. So if I want that solidification should start from here first and then proceed in this way, I can control that, right? कोप ऊपर वाले पार्ट को बोलते हैं, ड्रैग नीचे वाले पार्ट को बोलते हैं. कोप एंड ड्रैग के बीच में अगर एक और पार्ट हो तो उसको हम चीक बोलते हैं. चीक, कोप, चीक, ड्रैग. तो यू शुड बी नोइंग अबाउट दीज टर्म्स. कोप क्या होता है, चीक क्या होता है, ड्रैग क्या होता है, चैपलेट क्या होता है, चिल्स क्या होता है, कोर क्या होता है, कोर प्रिंट क्या होता है. यू शुड बी नोइंग दैट. अब डाई कास्टिंग इज फर्दर मेड अप ऑफ टू टाइप्स फ्रेंड्स, कोल्ड चैम्बर एंड हॉट चैम्बर. कोल्ड चैम्बर एंड हॉट चैम्बर. नाउ कोल्ड चैम्बर die casting is used for high melting point alloys to cast them, and hot chamber die casting is used for low melting point metals. So नाम सुनने में ऐसा लगता है कि ये कोल्ड चैम्बर है तो ये कम मेल्टिंग पॉइंट वाले मेटल्स को कास्ट करने के लिए यूज़ करेंगे, बट इट इज़ रिवर्स. कोल्ड चैम्बर डाई कास्टिंग, हॉट चैम्बर डाई कास्टिंग. हॉट चैम्बर डाई कास्टिंग इज़ फॉर low melting point materials, and cold chamber die casting is for high melting point materials. Cold chamber die casting is used for metal with high melting temperature that may be used, and typical materials aluminum alloys like brass, magnesium alloys and all. Low melting point are like zinc, tin are for hot die casting. So hot chamber die casting is used for zinc, tin, lead, which are low melting point materials, and cold chamber die casting is used for aluminum alloy, brass, which are magnesium, aluminum alloy. So aluminum, magnesium, brass, these are high melting point. These are high melting point alloys. So for them cold chamber die casting, and zinc, tin, lead, their melting point is low. They are used in hot chamber die casting. So there is a difference. I mean the table will tell you कि hot chamber में होता है, cold chamber में क्या होता है. तो furnace is directly connected to the chamber. Here आप बाहर से furnace is outside. In the cold chamber the chamber is cold because the molten metal in the furnace is outside. So the molten metal from the outside furnace is brought in ladle and poured here. chamber में डाली जाती है, उसको shot दिया जाता है, फिर the shot is given. diagram आएगा नीचे. So this hot chamber is for low melting point, cold chamber is for high melting point, right? So because hot chamber is at high temperature remains, so life is less, iska life is more. See this diagram, cold chamber, hot chamber die casting. So hot chamber because this is the furnace, ये plunger है, ये furnace का part है. So molten metal is here, and you will basically this entire system is at high temperature. You see furnace is somewhere else, and वहाँ से मैं hot molten metal को ला रहा हूँ ladle में, and I am pouring here. I am pouring here, and the plunger that is piston is pushing it. फिर ये cold chamber. Cold chamber why? Because furnace is outside. This is the furnace. So hot chamber, cold chamber die casting. I am sure you understood the meaning of this. So in die casting there is ejector pin. There is a moving die, half die, and fixed half die. Foundry crucible is made up of what? Graphite. It has high refractoriness, good thermal conductivity, ability to withstand high temperature, and thermal shock and chemical attacks. This is resistant. Graphite crucibles are widely used for melting non-ferrous and ferrous metal in foundries. सो फाउंड्री क्रूसिबल ग्रेफाइट के लिए इसकी बनी होती है. दिस इज मेड अप ऑफ ग्रेफाइट एंड व्हाई इट इज मेड अप ऑफ ग्रेफाइट दैट ऑल्सो यू शुड नो. Okay, so I think this is the electric discharge machining. By mistake this question is added here. So we are doing casting. Cast iron pipes are manufactured by what? These are manufactured by centrifugal casting. Pipes I told you centrifugal casting. So questions are asked from centrifugal casting. Carbon dioxide molding process, binder used is. In carbon dioxide molding, sodium silicate is used as a binder. So different casting processes में क्या binder use होता है, that also we should know. So sodium silicate is used as binder. Carbon dioxide gas, when it is passed through sand mixture, sodium silicate react and becomes hard. Advantage, mold hardening fast होती है, dimensional accuracy is good and high mold strength is obtained. And this is the equation when carbon dioxide, this sand consists of sodium silicate. This is called water glass. So sodium silicate is called water glass. So carbon dioxide gas will be passed through it. The gas will react. You see this sodium silicate with carbon dioxide and water. Then you get silica gel. Right? This is a sort of glass. तो एक solid आपका वो बन जाता है mold. Hardened, this mold gets hardened instantly, and drying time gets reduced. Now practice question, friends. On the basis of these previous year questions asked in casting, these were the questions asked in 2017 and 20. Now on the basis of this you can solve questions. So I am giving you a lot of questions for the practice and you can do, and exam mein you can expect that Coal India Limited mein questions are going to come from here. So gating ratio, yes, it is important. So what is A in gating ratio? A is the sprue area. Now see this sprue, this is runner, this is in gate. So sprue, cross sectional area of sprue, and then B is cross section area of runner, and C is of in gate. So A, B, C. Pressurized gating system, unpressurized gating system. So total gate area is not greater than that of sprue. So in pressurized gating system, sprue, runner, gate area are arranged to maintain the back pressure. So in pressurized gating system, I want to maintain the back pressure. Total gate area is kept smaller than or equal to sprue area, and that will basically full of molten metal during pouring, right? So air aspiration is minimized. So what we do is we keep this area to be more and sprue area to be less. So area of sprue and this area of gate and runner, this is kept more, this is kept less. So what is going to happen? This back pressure will be maintained, right? So sorry, this is areas A is more, this area of sprue is more than area of gate and all. So when this area is less, this area is more, back pressure will be maintained. More the area, more is pressure. Fluid mechanics mein you have studied that particular concept. If you go to Bernoulli equation, in the Bernoulli equation more is the cross section area, more is the pressure, right? So think it of not pressure is equal to force per unit area. Don't see that formula, because in that case force is dependent upon pressure. Pressure is not dependent upon force. Pressure is an independent entity. So pressure, Bernoulli equation will tell you wherever the pressure will be more in the flow of nozzle, area is more, pressure is more. So we keep area of sprue to be more than gate. So what happened? Pressure in the sprue will be more. So aspiration will be avoided, and at the same time back pressure will be maintained. That is called pressurized gating system. Pressurized gating system. So we typically use 1 is to 0.75 is to 0.5, or it can be 1 is to 2 is to 1, or 2 is to 1 is to 1. So something like this we maintain. Pressurized gating system ratio is basically gate area is smaller to create back pressure. So gate pressure is less. I am comparing this gate pressure with that of this, right? So gate pressure, area of sprue, area of runner, area of gate pressure. So if area of S is more than area of gate, so only here is 1, this is 0.5, other places, so C is the only choice, right? Pressurized gating system, unpressurized gating system. So typically is 3:2:1. So area of sprue is more than area of gate. Air aspiration effect is minimum. So smaller in this, velocity is high, severe turbulence may occur. Unpressurized gating system. So unpressurized gating system, greater flow rate with lower metal velocity. It reduces the turbulence and helps in maintaining the defect free casting. So I will be using larger runner and larger gates. So unpressurized gating system, where the cross sectional area of gate is more, so flow will be smooth. I mean, why pressurized gating system? It is used for ferrous and brass because back pressure is to be maintained full of molten metal rahe. Oxidation and air aspiration will be minimum, but metal velocity is higher, turbulence is there. One disadvantage of pressurized gating system is that high metal velocity may create turbulence in mold cavity. So turbulence may be there, relatively high velocity due to restricted gate area. So you must have seen in the pipes also, garden pipe, अगर area reduce हो जाए तो velocity of flow increases. As the area is less, Bernoulli equation, velocity of flow is more. Now think of in pressurized gating system, when the area of gate is less, so the velocity of flow will be more. Area of gate is less, velocity of flow will be more, and hence it leads to turbulence. Pressurized gating system, molten metal flows at high velocity through gates because the total gate area is smaller compared to sprue area. So again Bernoulli equation, if area is less, velocity is more, if area is more, pressure is more, something like that. So these are some questions about the pressurized and unpressurized gating system. So please try to do this, and also this diagram you see carefully. Pressurized runner with gates. So when pressurized runner with gates are there, then high velocity, jet effect, irregular flow. This is in gates, velocity is more. Right, so these are some questions related to that. Now what is aspiration effect in cast gating system? So aspiration effect is like, if I keep this cross sectional area to be uniform, at the top is the atmospheric pressure, pouring basin mein pressure is atmospheric pressure, you use Bernoulli equation at different places. If यहाँ पे pressure आपका atmospheric है और यहाँ पे आपका depth high है, तो आप Bernoulli equation लगाओ, you will find that pressure here will be less than atmospheric. But if the pressure here in the sprue is less than atmospheric, then the air will be sucked in. That is called aspiration effect. तो उसको कम करने के लिए हम area of cross section को reduce करते चले जाते हैं, something like this. Otherwise, what will happen if area of cross section is uniform? In this case, area of cross section is uniform. तो यहाँ पे aspiration मतलब negative pressure आ जाएगा. Why tapered sprue? To prevent the aspiration effect, negative pressure. Aspiration effect in casting produces which defect? Porous casting. What is the primary function of pouring basin in casting gating system? To maintain constant pouring head and to reduce the pouring force. Primary function of pouring basin is this. So which gating component will you specifically use to prevent slag and dross from entering the, so strainer is used in sprue to prevent the impurities. So strainer कहाँ use करते हैं हम? sprue में, to prevent the slag oxide dross from molten metal. It reduces the turbulence and prevent the contaminants from entering the mold cavity. Splash core, what is the function of splash core? To reduce the eroding force of molten metal as sprue base. Splash core ये होता है, देखो इसको डायग्राम ध्यान से. This is the pouring basin, this is the strainer in the sprue at the top side of the sprue, and the sprue cross section is reduced to take care of the aspiration effects, and the splash core is at the bottom of sprue, and the purpose of that is to prevent end of the sprue, to reduce erosion effect of molten metal. जैसे ही आपका molten metal changes the direction from vertical sprue to horizontal runner, तो turbulence ना हो, इसलिए splash core बनाया जाता है. Skim bob runner में होता है, again to prevent the impurities from entering into mold cavity. So cope, and this is drag. Skim bob, to trap impurities before metal enters the mold cavity. देखो, this is the, now three things are very clearly shown here. So this one is strainer in the sprue, this is the splash core, bottom of the sprue, and this is the skim bob in the runner. Heavier impurity नीचे की तरफ और lighter impurities ऊपर की तरफ. तो skim bob is for both higher, lighter and heavier impurities. Molten metal is poured directly into sprue entrance without proper control. What is most likely to occur? So vortex or turbulence flow, which creates the defected casting. Direct pouring into sprue entrance creates high turbulence and vortex formation in molten metal, जिससे gases, slag, impurities may enter into this hole. What is primary purpose of gating system? To direct molten metal smoothly into mold cavity. That is the reason I use gating system. So sprue is the vertical channel which enters the gating system. Runner, why they are designed with large cross sectional area than sprue? So to reduce the turbulence while lowering the velocity. So if the cross section area is more, friends, velocity will reduce. Bernoulli equation. So gating design may, please remember the Bernoulli equation if you want to understand the gating design. Impact of pressure, impact of velocity, impact of area, you need to understand through that. Main function of gates in casting gating system is to feed molten metal into mold cavity. Gating means at the entry of mold cavity. Cross section area decreases, velocity increases. Okay, so this is Bernoulli equation, as I told you. Turbulence I don't want, because it creates some kind of porosity, dross, inclusion and all. Why you increase the cross sectional area of gate? So larger the gate area, it reduces the velocity of molten metal before it enters the mold cavity. So this is the continuity equation. So why do you design sprue which is smaller than runner and gate? So smaller sprue will increase the velocity initially, but then later on velocity will get reduced, so turbulence will be less. So there is a facing sand. There is a concept of facing sand, and we should know about that concept of facing sand. So what is the meaning of facing sand also? This is when it comes into contact with the molten metal. Backing sand behind the facing sand, and larger volume is filled of the mold flask with backing sand. It provides the support to the mold. Facing sand is more expensive. Entire flask is filled with, in the mechanized foundries, entire flask is filled with system sand. Parting sand is basically applied on pattern surface to prevent mold surface from sticking together. So parting sand जो है वो पैटर्न और मोल्टन मेटल के बीच में आता है, सॉरी मोल्ड कैविटी के बीच में आता है. So high strength and refractoriness. Now refractoriness is the resistance to high temperature. Centrifugal casting is for hollow. Principle of centrifugal force. It rotates. जब ये रोटेट करता है मोल्टन मेटल डाला, it rotates at very high speed and then there is no need of core inside. तो hollow cavity वैसे प्रोड्यूस हो जाती है because molten metal goes on the extreme sides. One more thing, heavier impurities will be thrown towards the periphery. Heavier impurities will be thrown towards the periphery, and inside will be lighter impurities. Rotating motion, molten metal will be thrown on the other side. Uniform distribution. Hollow cylindrical components के लिए we use this centrifugal casting because core is not required, like pipes. So if the impurities are lighter, obviously impurities are lighter than the molten metal. So if impurities are lighter than the molten metal, so they will remain towards the center, जो ड्रिलिंग के थ्रू या बोरिंग के थ्रू रिमूव किया जा सकता है. और अगर heavier than molten metal impurities है, it will go to the, but heavier than molten metal impurities होती नहीं है. So you can see all molten metal will be thrown towards the periphery and lighter impurities inside. So pipes and tubes are produced by this. Centrifugal casting, dense casting with minimum defects, centrifugal casting. So what is the main force responsible for metal distribution? It is centrifugal force. So pipes and tubes, ये एक बार डायग्राम देख लेना फ्रेंड्स, you will understand the meaning of this diagram. The impurities are pushed towards center in centrifugal casting because due to centrifugal force acting on molten metal. Centrifugal force heavier चीज को बाहर की तरफ फेंकेगा. It will throw the heavier thing towards the periphery. What is the advantage of centrifugal casting over conventional casting? Production of dense casting with few defects. Core is not required and hollow pipes and tubes can be prepared. Intricate design and detailed pattern. So die casting is used for that. Component with intricate shapes, fine details, excellent dimensional accuracy. So molten metal is injected into metallic dies under high pressure. Precision components are made. Hot chamber die casting is most suitable for what? Low melting, that we have already discussed, hot and cold chamber die casting. So it is like 0.7 megapascal to 700 megapascal का pressure होता है in die casting. High maintenance cost because it is high pressure. हॉट चैम्बर डाई कास्टिंग का दूसरा नाम है गूज नेक कास्टिंग, क्योंकि गूज नेक बना होता है उसमें, सीधा डायग्राम, उसमें गूज नेक बना होता है. सी दिस इज द गूज नेक. So this hot and cold chamber die casting, please revise these all questions, you will surely understand these questions. Now investment casting is also known as lost wax casting. Wax pattern is used in the preparation of the mold. So what kind of pattern is used where, that is very, very important. So when you make the mold, the pattern is of wax which gets melted and removed before molten metal is poured. And the purpose is to produce highly accurate and intricate components. Right? Its name is lost wax, for which products very, very intricate components. टर्बाइन ब्लेड, सर्जिकल इंस्ट्रूमेंट, फायर आर्म्स, डेंटल डिवाइसेस, उसके लिए हम इन्वेस्टमेंट कास्टिंग यूज करते हैं. ये देखो क्या होता है इसमें, दिस इज अ वैक्स पैटर्न. ऑन द बेसिस ऑफ द वैक्स पैटर्न आई मेक दिस काइंड ऑफ पैटर्न्स एंड देन आई पुट इट इन द स्लरी. I put it in the slurry to make the shell, and then this is the slurry outside the wax. Then I heat it and then wax निकल जाएगा और वो slurry का पैटर्न बच जाएगा. फिर मोल्टन मेटल डालेंगे, मोल्टन मेटल डाल के वो आपका बेसिकली मेटल बन जाएगा, फिर उसको कट करके फिनिश कास्टिंग बन जाएगी. दिस इज हाउ इट गोज. सो दिस अ वैक्स फर्स्ट, आई मेक वैक्स ट्री, दिस अ ट्री ऑफ द वैक्स इज मेड, एंड फिर उस वैक्स की ट्री को हम घुमाते हैं स्लरी के अंदर, अब्रेसिव स्लरी के अंदर. फिर वैक्स के चारों तरफ स्लरी लग जाती है, फिर उसको गर्म करते हैं, वैक्स निकल जाता है, स्लरी रह जाती है, वो मोल्ड कैविटी बन गई. ऐसे होता है. वैक्स और प्लास्टिक के पैटर्न, वैक्स की जगह प्लास्टिक भी यूज हो सकता है. दे आर कॉल्ड एक्सपेंडेबल पैटर्न. सो देर आर 3 names you have to remember. Expendable, that means pattern will be consumed. Wax, plastic or polystyrene. And then they are basically coated with abrasive slurry or refractory material. Any kind of wax is to be removed, so they are by heated and they are fired and the wax gets removed, and ceramic shell is remained. So this is the pattern: wax, pattern making, investing, dewaxing, pouring. So we make use of refractory material slurry, high temperature refractory material slurry. Expendable pattern is made up of wax or plastic or polystyrene. So this we have done. So why do we apply refractory slurry to wax pattern? To create strong mold shell around the pattern. The pattern is of wax and you create strong mold around it. Right? So this investment casting you do, friends, that is how it is. And also I am giving you some more questions related to this now. So die casting, investment casting, slush casting, and some slush casting is basically used to produce hollow thin castings, hollow thin casting walled products like ornamental things which you want to make, decorative toys, alloys, shell, slush casting, lamp shades and all, ornamental casting, basically slush casting. Molten metal is retained inside the mold cavity for very small time, and the thickness depends upon the time. So if for very less time it is kept inside, the thickness will be very less. Injection molding is something which is related to thermoplastics. Right, so core and what is the purpose of core, print, those things you should be knowing. So I am giving you this document, friends, just to go through this entire document. This is related to your casting, and in my opinion, in Coal India Limited, all the questions are going to come from this only. So special casting processes, some casting defects will be provided to you. So the questions will be provided to you in the test also, from where you can answer it. And keep watching various other such videos made by the mentors related to Coal India Limited. and the exam of Coal India Limited is basically asking questions from particular domain only. सारे के सारा नहीं करना है, कुछ जगह से questions आ रहे हैं, उसको ढंग से करना है और आपको टेलर मेड प्रिपरेशन करनी है फॉर कोल इंडिया. सो प्रिपेयर ऑन दैट लाइन एंड mentors of YourPedia will provide you specific questions related to these domains. Thank you.